Welcome back to Science Online. My name is Rajesh. In today's video, I will be explaining gravitational potential energy, kinetic energy, and energy conservation theory. This video is for GCSE Physics students. At the end of this video, you should be able to explain these two forms of energy stores and how to use the law of conservation of energy in physics calculations. So let's start. The gravitational potential energy is the energy stored in an object due to its position in the gravitational field. The gravitational potential energy can be calculated by multiplying the mass of the object times the gravitational field strength times the height of the object above the ground level. The unit for the gravitational potential energy is joules. The mass must be in kilogram, gravitational field strength Newton per kilogram, and the height in meters. As you can see in the equation, the gravitational potential energy depends on two factors: the mass of the object and the height where the object is positioned above the ground level. So, if the object is on the ground level, its height is 0. Therefore, the gravitational potential energy also 0. Let's do a calculation. In this example, the object is placed 2.5 meters above the ground in a gravitational field strength of 10 Newton per kilogram, and the mass of the object is 1.5 kilogram. If you apply the equation, gravitational potential energy equals mass times gravitational field strength times the height. If you apply the values to the equation, the answer will be 37.5 joules. Kinetic energy is an energy an object has due to its movement. This energy can be calculated by using the equation kinetic energy equals half times mass of the object times speed of the object squared. The unit for the kinetic energy is joules, mass in kilogram, speed in meters per second. As you can see from this equation, the kinetic energy of an object depends on two factors again: the mass of the object and the speed it's traveling. Therefore, if the object is stationary, its speed is 0, therefore kinetic energy also 0. Let's try a calculation. In this example, the object is traveling at 30 meters per second speed, in this case is a car, and its mass is 200 kilogram. If you apply that in an equation, kinetic energy equal half mv squared, the answer will be 90,000 joules or 90 kilojoules. In terms of units, if the answer is in bigger value, like in this case 90,000 joules, you can convert that to kilojoules. However, in your exams, sometimes you will be asked to provide the answer in a specific unit. If not, you will lose the marks for that. The law of conservation of energy. It states that energy cannot be destroyed or created. Rather, it will be changed from one form to another. So the energy is conserved all the time. Let's explore this with a simple example. In this example, as you can see, an object is placed on top of a desk. Because the object is above the ground, it has a height, therefore it has gravitational potential energy. But the object is stationary, and therefore its kinetic energy is 0. If the object is falling from the desk, it is coming down from the desk, it's losing its height, and therefore is losing its gravitational potential energy. However, it's picking up speed, therefore its kinetic energy is increasing. So please note there is an energy conversion is taking place here. The loss of gravitational potential energy is equal to the gain of kinetic energy. Also please note we are ignoring the air resistance here. So when the object just before it hits the ground, it has its highest kinetic energy and the gravitational potential energy is almost 0. Once the object hits the floor, Now the object is on the ground and it's not moving, and therefore both kinetic and gravitational potential energies are zero. So what happened to all the energy it had before? It's now lost to the surroundings in the form of heat or sound. So you can see the energy took different forms throughout the process. The idea of this conversion of energy has been tested repeatedly in the past GCSE physics exam papers. So having a clear understanding of this concept is very important. There are a few things you need to note when you do calculations in this topic. First, using the right units is important in order to get the full marks. Second, you have to use these energy conversions correctly in the right place. Hope you find this video useful. Until I see you in another video, bye to everyone.